Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Vitamath 20, here is the problem. In a right triangle with a hypotenuse of 25, the altitude drawn from the hypotenuse to the right angled corner is 10 units. Find the ratio of the longer segment to the shorter segment of the hypotenuse cut by the altitude. What is the maximum area possible for this right triangle? What is the maximum height of the altitude to the right angled corner for the area of the right triangle to be calculable? Can you find the area of the right triangle if the length of the altitude is 13 units? So those are the questions out of this problem. And this problem on right triangle is already discussed in the preceding Vitamath series. And remember that in a right triangle, the hypotenuse is the diameter of the circumscribing circle. And this altitude from the hypotenuse to the right angled corner is also the mean proportional between the segment it cuts on the hypotenuse. So since h is perpendicular to the base, which is the hypotenuse, then h squared equals a times b. That's the relationship. And if we consider b as the longer segment, then we're looking for b over a. Then that h squared equals ab is already presented in the preceding Vitamath series, and in fact I presented many ways in deriving that. So we're looking for b over a and h squared equals ab, and to recall that this angle is equal to that angle, so we have two similar triangles in order to define that. So that's one way of showing that this is the formula for the square of the altitude is equal to the product of the segments it cuts. And AB, the hypotenuse A plus B, is 25, which is the diameter of the circumscribing circle. So that's we are after for the first question. So this is the diameter, 25, 2r. So if this is the center, because this is the diameter, then the center to the right angle corner is also the radius, because we can always circumscribe a circle about a triangle. So that's r, which is half of 25, 12.5. So a plus b equals 25. Substitute into this equation with h 10. So 10 squared equals a, and b is 25 minus a. So 100 equals a times 25 minus a, expanding 100 equals 25a minus a square, rearranging a square minus 25a plus 100 equals 0, which can be factored into a minus 5 times a minus 20 equals 0. So since a is shorter, the other value of a, which is 20, that should be b. So a is 5 and a is 20 supposedly, but with our designation here, we'll just take a is 5 because the other value of a is supposedly b, 25 minus 5, so it's 20. Therefore, when a is 5, then b is 20, and b over a, 20 over 5, is 4. So that's the answer to the first question. Then, what is the maximum area possible for this right triangle? So based on the figure, the height h should be maximum equal to the radius. So it should be the radius, so that is the center is directly below this right angled corner. In other words, it should be an isosceles right triangle where the two angles should be 45 degrees each. So this is the situation. So h max equals radius, and A equals R, B equals R also. So therefore, the area of the triangle 1 half base times height 1 half 2R times R. Area max equals 1 half of quantity 2R times R. So area max is R square and R is 12.5 quantity square. So maximum area for this triangle is equal to 156.25 square units. Then what is the maximum height of the altitude to the right angled corner for the area of the right triangle to be calculable? So the maximum height for the area to be calculable is the radius of the circumscribing circle, which is 12.5. So H max should be less than equal to R and R less than equal to 12.5. So in this case, H max is 12.5. Can you find the area of the right triangle if the length of the altitude is 13? If the length of the altitude is 13 and the hypotenuse is only 25, then there's no such triangle of that case. So the area cannot be calculated because there's no triangle that will satisfy that uh, property with altitude to the right angle corner 13. It is greater than the radius, so it is impossible. So no such triangle as our conclusion. So that's it, and I hope that you learn another concept in plane geometry, and I hope that you will be able to bring this in your engineering lifelong experience so that uh, you can use this in your future encounters with situations where you need to recall this concept.